Hello everyone, welcome back to my video. In this video, we'll solve some topical questions for mensuration. Let's get started. Now, this isosceles triangle has a perimeter of 35.5 centimeter, and you can see these two lines. This shows that these are both 3a plus 2, like the lengths are equal. Now the third length is a. So the perimeter basically means add all sides. So 3a plus 2 plus 3a plus 2 plus a. This equals to 35.5. Now we can simplify this. Since it's just they're all being added, we can easily remove the brackets. 3a plus 2, 3a plus 3a plus a plus 2 plus 2, which is 35.5. This is going to be 7a plus 4 equals to 35.5. So a is 31.5 divided by 7, which is 4.5. Now, A, B, C, D are points on the circle center O. TA and TC are tangents to the circle. They told us OA is 6.75 and OT is 11.5. Show that angle AOC is 108.12. Okay, so we're supposed to find this big angle AO and C. Now AOC can be is double of AOT, so we'll just divide it and then later we'll multiply by 2. And we can find the angle AOT using SOHCAHTOA rule, because you can see that triangle AOT is a right angle triangle. So TO is our hypotenuse, AT is the opposite side, and this is adjacent. Now we have the hypotenuse and we have the adjacent, so we can use the cosine rule. Cosine AOT is going to be A over cos CAH, adjacent over hypotenuse. This is going to be 6.75 over 11.5. Now we can find AOC, which is just 2 into AOT. 2 times cosine inverse 6.75 divided by 11.5. And the answer is 108.12 as mentioned in the question. Calculate the length of minor arc A, B, and C. Alright, so A, B, and C is the length of a sector. This is what we're supposed to find, and we can apply the formula, which is theta over 360 times 2 pi r. Now our theta is 108.12. We just found that. Divide by 360 times 2 times pi times 6.75. OC is the radius. OA is also the radius. So we get 12.7 centimeter. Calculate the area of major sector OCDA. So if we consider this diagram, this OCDA, this is the major sector. The smaller one is the minor sector, and this is the major sector. So if we subtract this whole circle and we remove the smaller sector, we get the area of the major sector. And that's the approach that we'll follow. We'll find the area of circle first, which is pi r squared. The area would be 143.13 for the whole circle. Now we're supposed to find the area of the minor sector. Recall that the formula for area of sector is theta over 360 times pi r squared. So here we can apply that as well. Theta is 108.12 times over 360 times pi times 6.75 square, which equals to 42.989 centimeter square. Now to calculate the area of the major sector, we will just subtract both of them, which area of circle minus area of minor sector. 143.1388 minus 42.989. When you're calculating, it's better to write more decimal points to get more accurate answer in the end. Here we get 100.14 centimeters square. That's the area. Now a rectangle has an area of 9400 centimeters square. Correct to nearest 100 centimeters square. The length of a rectangle is 80. Correct to nearest 10 centimeter. Calculate the upper bound of the width of the rectangle. Okay, so we have the area and we have the length. We need to find the width, and we know the formula of area is length times width. So width is going to be area divided by length. Now to find the maximum area, we need to, because we're finding the upper bound, we need to find maximum width. We need to use maximum area divided by minimum length. You need to learn that, because, or you can say that since the W and A are on the same level, they're both high. Length is on the bottom level, is in the denominator, so we have used opposite. We have used minimum. That's like a trick that I like to remember. So to calculate maximum area, 9400 plus 100 divided by 2. Now to find the lower minimum length, 80 minus 10 divided by 2. Now they told us it's nearest 100, nearest 10, make sure to divide by 2. So that would be 9450 divided by 75, which is going to be 126 centimeter. The diagram shows a tank in the shape of half cylinder of radius 12 centimeters. So this is a half cylinder, and it has a length of 1 meter. The tank is fixed horizontally and is completely filled with water. So all of this is has water inside, right? Calculate the volume of water in the tank. Give your answer to the nearest 10 centimeter cube. Now, in order to do that, you first need to find the volume of a cylinder and then divide it by 2. So volume of a cylinder is going to be pi r square h. Remember to learn this formula, it's an important formula. Now, so here volume is going to be half, because we're dividing by half, multiplied by pi into radius is 12 times 12 square times this is, remember, we need to convert this into centimeters, so we cannot use this. 1 meter is going to be 100 centimeter times 100. Now you can calculate it with the calculator. Half times pi times 12 square. The answer is going to be 22619.46. So divide it to nearest 10 centimeter. These two, 226, 19 becomes 20. So this is our written nearest 10 centimeter. All right. The water is removed from the tank until the level of water is 6 centimeter below the top of the tank. 6 centimeter below the top of the tank. Diagram shows the cross section of the tank. Calculate the volume of water in the tank. Now, if you notice, this is not an identifiable shape. It's not a sector. It's not a semicircle. So what do? So we have to divide this shape into a shape for which we can find some areas and volume. So to do that, let's divide this into a triangle. Now if you see, this shape is like a sector. So we to make it easier, we can label it. You can give it any number, but I'm giving it A, O, B, C, M, D. In the marking scheme, they chose these letters. But so what you need to do is find the volume of this sector, COD, and subtract it by the triangle, the volume of triangle. So the formula will be volume of water equals to volume of sector, COD, minus volume of sector, volume of triangle, now COD. Now how do you find the volume of these ones? We just write area. Volume will be volume area times height. Okay, so we'll find the area of sector, COD, minus this is going to be area of sector, COD, minus area of triangle, COD, multiplied by 100, because our height is 100. This times 100. Now let's try to find these values here. So what is the area of let's try to find more. Let's try to find the area of triangle. Now if you notice, you can, this is basically a right angle triangle, right? COM and and this one MOD, these are both right angle triangles. So we can use SOHCAHTOA to find this angle, and then we'll multiply by 2 to get this entire angle COD. So how do we do that? This is the angle that we're looking for. This is opposite. This is H and this is A. So we know CO is 12 centimeter. 12 centimeter. This is also 12 centimeter. So we have hypotenuse and we also have adjacent. So SOHCAHTOA. So we can use cosine rule. COM is going to be cosine minus 1. Adjacent here is 6 divided by hypotenuse, which is 12. Okay, so COM is going to be 60. Now what is COD? So COD is 2 times 60, right? That makes it 120. degrees. Now we can find the area of this triangle first. Sorry, that's a wrong pen. Area of triangle is going to be half times 12 square times sine COD is 120. Let's calculate it. So area of triangle here is 62.35 centimeters square. Now we can find area of sector. Area of sector will be 120 divided by 360 multiplied by pi times 12 square. So calculate that. This will be 150.8 centimeter square. So now we can plug it in the volume. 150.8 minus 62.35 and then multiply it with 100. A solid cylinder has a base radius xx and height 3x. Okay, so we have a cylinder. This is the cylinder, right? I'll also use another pen here. Now the base radius is x, so this is x and its height is 3x. This is x and 3x. The total surface area of the cylinder is same as, so this is same as the total surface area of a solid hemisphere. A hemisphere is basically a sphere divided into half, so this is going to be something like this. But the key thing to remember here is that they're saying total surface area, all right? So that means this sliced area is also considered to be part of the total surface area. So this and this. Now they're saying the total surface area is equal, right? So we need to equate both of them. Alright, so what is the total surface area of the cylinder? It's going to be 2 pi r h plus the area of these two side squares, this and this. So it will be 2 into pi r square. So now we can add in our values. 2 pi times x, 3x, 2 pi r square, 2 pi x square. So we get 10 simplified into square plus 2 pi x square. We can find TSA of cylinder, not cylinder, the hemisphere. So the formula is of a sphere, it's 2 pi r square. 2 pi r square. But since this is a hemisphere, surface area, total surface area of a sphere is 4 pi r square. But since this is a hemisphere, we'll divide this by 2, plus we need to add this area as well, which is pi r square. This will be 2 times pi. Now radius is 5y. 5y square. Don't forget to add your brackets for both 5 and y. Pi 5y square. So we can write this as 2 pi times 25y square plus pi into 25y square. This will be 50 pi y square plus 25 pi y square. Now we're supposed to equate this and this. That means we have to make both of them as equal. So TSA cylinder equals to TSA hemisphere. Write the whole thing. 6 pi x square plus 2 pi x square equals to 50 pi y square plus 25 pi y square. I just want to separate the two. Now if you see, they want x on one side, y on the other side, and just simplify them as much as possible. So this can be 8 pi x square equals to 50 plus 25 is 75 pi y square. X square is going to be pi and pi gets cancelled, and we're almost there. 75 y square divided by 8, and this is the final answer. Okay, OAB is a sector of circle, center O, radius centimeter. So we have one sector A or B, and we have another sector OCD, which has the radius of 10 centimeter. OCA and ODB are straight lines, and they have the angle of 60 degrees. The perimeter of the shaded shape ABCD, which is this area, can be written in the form as A pi plus B centimeter. Find the value of A and the value of B. Now to find the value of A and B, we need to find the perimeter. Okay, so perimeter here is going to be AB plus BD plus CD plus AC. Okay, so that means we're supposed to find the length of this one, of this sector, plus this line, plus the length of the other arc, length of arc of the other sector, and then this line as CA. Now if you know CA and DB are same, CA equals to DB, which is just 17 minus 10 equals 7 centimeter. So this is 7. Right, now we can find, I would like to move this over there. So we already have 2. 7 plus 7. Now we need to find AB and CD. AB is length of arc. What is the formula for length of arc? Is theta over 360 times 2 pi r. Here 60 divided by 360 multiplied by 2 pi, and r is 17. For CD is going to be same as well. We'll just change the value of radius times 2 pi times 10. Let's calculate it. 17 divided by 3 pi. This is 10 divided by 3 pi. So let's add it here. 7 plus 7 plus 17 by 3 pi plus 10 by 3 pi. Now they want us to write in the form a pi plus b. So let's try to add these two numbers first. We get 9 pi plus 14. So a is 9 and b is 14. The diagram shows a regular hexagon. The area of the hexagon is 127.3. Show that the length of one side of the hexagon is 7 centimeter, correct to 1 decimal place. Okay, they have given us the area, which is 127.3, and they have told us that each side is 7 centimeter, but we have to find out how. Now to do that, we can basically divide this hexagon into little triangles, because we don't know the formula of the area of hexagon, right? But we do know the formula of area of a triangle. Now if we can find the area of each of these triangles is 127.3 divided by 6. 1273 divided by 60. Let's just write that, and we'll use in decimal in the end. Now let's try to find one of this angle. So all of this is 360 degrees. So what is each angle going to be? Angle is going to be 360 divided by 6, because it's all of the angles are equal. So, and 360 because angle around a point is 360. That means each of these angle is 60 degree, and area of each of this triangle is 1273 divided by 60. Now calculate the length of one side of the hexagon. Now this length, and this length are equal. Based on that knowledge, we can try to find the length. Let's try to find the area of triangle, which is half times a times b times sine theta. So half times L square times sine 60. L is going to be 273 divided by 60 multiplied by 2 divided by sine 60. The answer is 6.999, which is 7 centimeter if we correct to 1 decimal place. Now the hexagon is the cross section of a prism of length 10 centimeter. Calculate the volume. So volume is going to be area times height, 127.3 multiplied by 10. So it's going to be 1273. All right, calculate the surface of area of the prism. So we need to find the area of this region, this like all the exposed region basically. Okay, so to do that, we will add the area of this side, this hexagon, and there's also another hexagon on other side, right? So first it's going to be 127.3 multiplied by 2. So we have this, plus we have these side rectangles, and we have 6 of them. So we'll multiply 6 times this is 10 and this is 7. So 10 times 7, and we get 674.6.